Hello, gals and guys. This is Mr. Ambrose here. I wanted to make this video to explain the solution I posted for question number 5 from Thursday's homework. On this particular problem, you were told that point M, which had coordinates t, 4/7, is located in the second quadrant and is on the unit circle. You were asked to determine the exact value for t. Well, the first thing I'll highlight here is that the point is on the unit circle. And remember, whenever you're on the unit circle, the x-coordinate, which in this case is t, will always equal the cosine of the angle theta that rotates us to that particular point. And the y-coordinate, which is 4/7, equals the sine of the angle theta that rotates us to that particular point. So that's going to be really helpful. And in any one of these problems, no matter whether you have the unit circle or not, if you're given some information and you're asked to solve for a specific trig function, we can always draw a right triangle. And so I'm going to do that as well. And I'm going to draw my right triangle in the second quadrant because that's where this point M is located. So I'll go and draw my coordinate plane. And again, there's an angle theta that rotates us to this point M on the unit circle. So I'm going to draw the terminal side to that angle. And right, this is our angle theta. And now the thing is, the point M, when I make my right triangle here, and I made my right triangle in the solution key, the point M is on the unit circle. But I don't want to actually use that point M. I mean, maybe point M is over here, but I would rather choose a point over here instead that is not on the unit circle to actually answer this particular problem. And I'll explain why in just a second. So this is a point that's on the terminal side of this angle, and from here I draw a perpendicular down to the x-axis. And here's our right triangle that I'm going to use to help ultimately solve for the cosine of angle theta. The reference angle to this angle theta is located right here in my right triangle. And as I did in all the problems that I showed in the video and in my solution key, I'm going to start labeling the sides of this right triangle. And I'm going to do so by using the fact that we know that sine of angle theta is equal to 4/7. And in a right triangle, we know that the sine of an angle can be obtained by looking at the opposite side over the hypotenuse. So in this right triangle, always from the perspective of the reference angle, I'm going to label the opposite side to this reference angle as having value of 4, and the hypotenuse I'm going to label as 7. And then from here, we're going to need to solve for what this side x is here. And we can do that by utilizing the Pythagorean theorem. But the point M, I didn't want to label this as point M because technically this would not be the point M. M is on the unit circle. And so if this was point M, I claim that this hypotenuse would not have value of 7. It would have to have a value of 1 because this is the hypotenuse is the same thing as the radius to the unit circle that goes to that particular point. And this side here wouldn't have value of 4, it would actually have value of 4/7. And I want to try to avoid really dealing with fractions in my solution. And so that's why I constructed my right triangle this way, as opposed to perhaps actually placing this point on the unit circle and draw my right triangle from there. So again, this triangle, it's going to be easier for me to now solve for the side x because I'm not going to have any fractions to deal with, and I'll go ahead and do that now. Solving for x using the Pythagorean theorem, I would have 4 squared plus x squared equals 7 squared, and 4 squared we know is equal to 16. 7 squared is equal to 49. We can subtract 16 from both sides, and 49 minus 16 is 33. And then to solve for x, we could just take the square root of both sides, We have to be careful because we're taking the square root, we have to consider plus or minus as a potential answer. So x should equal the plus or minus of the square root of 33. In these questions, when you go to label your legs, you do want to be cognizant of assigning it either a positive value or a negative value. And since we're on this part of the x-axis where x has negative values, I'm going to assign this leg of the right triangle to be negative square root 33. And then now that I have this right triangle properly labeled, I can solve ultimately for what t is, because again, t is equal to the cosine of our angle theta, and we can use this right triangle to evaluate the cosine of the angle theta. And in this right triangle, right, the cosine of angle theta, well, we go from the reference angle, and from this reference angle, the adjacent side is this square root of 33. And that's square root 33. And then the cosine of theta is the adjacent side over the hypotenuse, and the hypotenuse is equal to 7. And so there's our answer for what the value of t is. So I hope this video helped explain question number 5 from the homework. And if you have any questions on any of the homework problems, please don't hesitate to send me a message, and I will definitely try to answer your questions in a timely manner. I hope everyone has a great weekend. Take care and stay safe, everyone.